All right, question number 11. If AB equals 6, BC equals 4, and AE equals 9, find ED. You guys okay if we call ED X? So I'm going to put the X right there. When we have two parallel lines in a triangle like this, that takes the sides of my triangle and splits them up into these proportionally equivalent segments. So on this side of the triangle, I'm going to take those two numbers, the 6 and the 4, and I'm going to make a fraction out of those. It doesn't matter which one I put on top and which one I put on bottom. But whichever one I decide to put on top here, I have to choose the corresponding piece on the other side. So we have this 6 over 4 equals, and now I go to the other side of the triangle, and we're going to make a fraction out of these two pieces. Since I put the 6 on top of this fraction, which of those two pieces do you think has to go on top of the second fraction? 9. We'd have 9 over x. And now we're going to solve this for x. We have two fractions, so we're going to have to do multiplication twice to get rid of both denominators. So let's get rid of the denominator of x first. I'm going to multiply both sides by x. Cancels my denominator on the right. On the left, the x only multiplies to the numerator. Thank you. So when I simplify this after multiplying by x, I have 6x over 4 equals 9. And then we get rid of our other denominator by multiplying both sides by 4. Cancels my denominator on the left. And that gives me 6x equals what? 36. Finally, to finish this off, we do what? Divide both sides by 6. And 36 divided by 6 gives me 6. So ED is 6. What other problems would you guys like to look at? 17? Absolutely, I can. Let me get there on my paper. Number 17, use the triangle to the right to answer the following questions. Write an equation to find the value of theta, then find theta. Well, theta is this angle down here. Does anybody remember what we used when we wanted to find angles like this? When all we had to work with was sides and we wanted to find angles? Yeah, sine, cosine, tangent, except we couldn't use just regular sine, cosine, tangent. We had to use what? The inverse, the one with the little -1. If you don't have this written down somewhere on your cheat sheet, I would absolutely get this written down. When you want to find an angle, you have to use inverse sine, inverse cosine, or inverse tangent. We decide which one to use the same way we decide when we want regular sine, cosine, or tangent. We're going to label our sides, and we're going to do SOHCAHTOA. All right, so let's label these sides up. Standing at theta, which side is the hypotenuse? 18 is my hypotenuse. Opposite from the right angle is my hypotenuse. Which side is opposite where I'm standing at theta? 12, yes. This is my opposite side. And so that means the side there that is x is which side? The adjacent. All right. When we are solving equations, we are only allowed to have one unknown thing at a time. So since we're trying to find the angle, I have to use sides that I know the numbers for. So we're going to have to use the hypotenuse and the opposite side. I can't use the adjacent because that's x. I don't know how big x is. I have to have numbers for everything except the angle. Which of these three up here uses opposite and hypotenuse? Sine, opposite and hypotenuse. This one uses adjacent. That's where x is. We're not using the adjacent side. TOA also uses the adjacent side. All right. So my equation that I'm going to solve is to say the inverse sine, and then inside the parentheses is where I put my opposite over hypotenuse. What are we going to put for opposite over hypotenuse? 12 over 18. I need you to put that away, please. Is equal to theta. Victor, I need you to put your phone away, please. From here, we take it and pop it into the calculator. Inverse sine of 12 over 18. Grab a calculator. If you need to go up and borrow one, you absolutely are more than welcome to. What do we get when we do the inverse sine of 12 over 18? 41.810, so 41.81. And then part B asks us to find x. Is x a side or an angle? Side. How many other sides do we know? 2. This is a right triangle, right? What do we use when we know 2 sides of a right triangle and we want the third side? Pythagorean theorem. That's not an equation. That's a formula. We're going to use a squared plus b squared equals c squared, but that's not an equation that I can solve, so that's not what I'm going to write on my equation line. I actually have to plug the numbers in for it to count as an equation. Which piece has to go in for c? 18. Hypotenuse has to go in for c, so we have 18 squared in the place of c. Put it away, please. What goes in for a and for b? 12 goes in for one of them, and the other one just stays a variable. So 12 squared plus b squared, or a squared plus 12 squared equals 18 squared. So then we solve this. What is 12 squared? 144 plus b squared equals, what is 18 squared? How much? I still can't catch the second number. 324, thank you. I apologize. I just couldn't hear that second number there. So then we subtract 144 from both sides. And we get what for b squared? 180. And now what? Square root. If you do it to one side, you got to do it to the other side. Now, did the directions say whether we were supposed to give our answer in exact form, radical form, or decimal form? Didn't say, right? So let's go ahead. For this one, we're going to write our answer down both ways. What is it when you just pop it into the calculator before you hit the back and forth arrows? 6 square root of 5. Or in decimal form, that would be how much? 13.416. Be prepared for either type of answer, especially if it's a multiple choice question. It could show up either way in possible answers. This was the unit where we learned how to simplify radicals. So on a question like this, it would be possible for me to ask for it in radical form, in exact form. Or I might ask for it in decimal form. Either one is a possibility. What else would you guys like to see? Number 9? Absolutely. In the figure, JK is parallel to QR. By what rule is triangle JKZ, and then it has this squiggle. As a reminder, that squiggle means similar. By what rule is triangle JKZ similar to triangle QRZ? So we had 3 different ways that we could show 2 triangles similar. We had angle-angle similarity. We had side-angle-side similarity. And we had side-side-side similarity. To use side similarity, you have to know about all three sides on the top triangle and all three sides on the bottom triangle. Do we know about all of the sides on both triangles? No, then side is not going to work out for us. Side, I have to know about one angle, and I have to know about two sides on one triangle and corresponding two sides on the other triangle. So 4 sides total between the two triangles. Could I use side, angle, side? No. So we're going to have to try to use angle, angle. Looking at the picture, there's something that I can mark about an angle right now without knowing anything else, just the picture by itself. Vertical angles, yes. Right here and right here. Angle JZK is congruent to angle RZQ because those are vertical angles. And now we're going to make use of these markings here, which mean parallel. Does anybody remember what letter we draw when we see parallel lines? A Z. I could draw my Z like this, or I could go the other way. I could draw my Z like this. It does not matter which way you go. Why don't we go this way? If I draw my Z like this, I'm going to go to the corners, thank you, where I can match up orange to orange. So up here at J, I can go orange to orange here, and that would correspond to what on the other triangle? Q. Angle J is congruent to angle Q. Does anybody remember what type of angles those are called? I said I'm getting tired of having to babysit. Put it away. Like, this is not that hard. Put it away and leave it away. If you don't want to participate, that's fine, but you cannot be on your phone. I'm sorry, one more time. Does anybody remember what type of angles it is when we find by doing the Z? Yes, alternate interior angles. So we could make the statement that triangle JKZ is similar to triangle QRZ by angle, angle similarity. Are you going to be working on this?
We'll do work.
Okay. What other questions would you guys like to look at? Which one? 14, absolutely. Question number 14. Determine what type of triangle the following side measures would make: acute, obtuse, or right. So for an acute triangle, we would know it's acute because c squared would be smaller than a squared plus b squared. We would know it's obtuse because c squared would be bigger than a squared plus b squared. Does anybody want to take a guess on how we would know it's a right triangle? Equal. C squared is equal to a squared plus b squared. C has to be the biggest number. So looking at these three choices for sides, which one would have to be C? 13. Here's C because it's the biggest. All right, so c squared, and I don't know whether that is equal to, greater than, or less than a squared plus b squared. We're going to put 13 in the place of c, so I would have 13 squared. Don't know what goes here. What goes in for a and for b? 7 and 12. We have to take both of those numbers and square them and add them together. Thank you, sir. What is 13 squared? 169. 7 squared? 49. 12 squared? 144. What do we get when we add 49 and 144 together? 193 on this side, 169 on the other side. Alligator eats which one? The bigger one, which is? The 193. So what type of triangle is this? Acute.
Wait.
Remember, c squared was on this side. If c squared is smaller than the other two, c squared is smaller. This is the sum of those two added together. These two added up to be bigger.
So what bigger means is an acute angle? The right side means the right side?
If the right side is bigger, then it's acute. If the right side is smaller, then it's obtuse. Yes. So this is an acute triangle. What else would you guys like to see? 12, absolutely. Number 12, VR, VZ, and ZR are mid-segments. So VR, that's this one right here. VZ, that's this one right here. And ZR is this one right here. If those are all mid-segments, then V, Z, and R are all midpoints, which means that UV and YV are congruent. UZ and WZ are congruent, yes. YR and WR are congruent. Now, when we learned about mid-segments of triangles, one of the special properties that we learned was that a mid-segment and the side of the triangle that it is parallel to, so this one right here, the side of the triangle is twice as big as the mid-segment. So if my mid-segment is 25, each of these little segments here would be 25 because it's twice as big. So UY is equal to 2 times ZR. What'd you say? 25 from right here. In the place of UY, we're going to put X because that's how it's marked on the picture. UY is marked with an X right here. That would be equal to 2 times 25. So X would be 50. What else would you guys like to see? So you want to check out the videos to help you with the last part. I apologize. Which one? 10. Absolutely. Problem number 10. Determine if the triangles are similar. If yes, write a similarity statement and reason. If not, explain why. So again, my reasons for similarity are angle-angle similarity, side-angle-side similarity, and side-side-side similarity. Can we use side-side-side similarity here, do you think? No, why not? We don't have all the sides on both of the triangles, so I can't use side-side-side. Angle-angle. Do I know about any of the angles in the picture? Yes, I know about one of them, right? Because one pair of angles is what? vertical angles. We've got this angle right here is a vertical angle with this one right here. So those are congruent. So we have at least one pair of angles. Do we know about any other angles? Do we know that the lines are parallel? No. It would either have to tell me up here, or they would have to have the little arrows on there. Otherwise, they just look parallel, but for all I know, they're not actually like this. They're like this, and I'm just zoomed in so close that I can't tell. So angle is probably off the table. So we're going to have to try for side angle side. For side angle side, I have to know about two sides on one triangle, the corresponding two sides on the other triangle, and at least one angle. Do I have something that could work like that? Yes. Okay. So my top triangle, ABE, right here. The two sides that we know about are 4 and 6. And then we have triangle CDE down here. And the two sides that we know about here are 12 and 8. The way I match these up to see if they are proportional, because if they're proportional, then this is similar, I have to be careful in how I match these sides up. We want to match smallest to smallest and biggest to biggest. What's the smallest side on the top triangle? 4. That would have to correspond to the smallest side on the other triangle, which is how big? 8 on the other triangle. That's okay. Yeah, we want one side of one triangle and one side of the other triangle. Smallest side on the top to smallest side on the bottom. So I would have 4 over 8. I could do big triangle over little triangle. That would be fine. But you have to stay consistent when you set up the other fraction. So since I put the 4 on top here and that came from my smaller triangle, the other numerator also has to come from the smaller triangle. So what do I put up there? 6 here. And on the bottom? 12. And now I'm going to simplify those two fractions and see if they are the same. 4 over 8 is what when it's been fully reduced? No, not 2, but you're close. 0.5 or 1 over 2. What about 6 over 12? Same thing, we get 1/2 or 0.5. Those came out to be the same. So the sides are proportional. Which means they are similar. They're similar by side angle side similarity. The similarity statement. I have to write a statement like they gave me back here on this one. Do you guys remember this problem? So I have to write a statement like that, but about these two triangles. And you have to make sure to match up the corresponding parts. The first triangle I can name any way I want to. The second triangle I have to make sure to match up those corresponding pieces. So give me a name for the smaller triangle. AEB. Triangle AEB is similar to, all right, I have to make sure to match up corresponding pieces. We know this is my vertical angle. What's the vertex of that angle? E. E is in the middle here. So on my other triangle name, I need E in the middle. I believe so. The next thing I have to look at is these two letters here, AE. Let's go find that segment. Here's AE. What did I match that up to on the other triangle when I made my fractions? DE. So that has to go at the beginning over here. So DE and then C. All right. What else would you guys like to see? Yes, but what other problems from the packet would you guys like me to work through? 18. This is a good one. 18 has some rules that I would absolutely make sure to get down on my cheat sheet. It says we are supposed to solve this using special right triangle rules. So we're going to write those down. Make sure to give you an opportunity to get them on your cheat sheet. And it says our answers have to be in radical form. If it says that it's in radical form, that means absolutely no decimals. My answers can be whole numbers, or they're allowed to have a square root in them. But they are not allowed to be decimals. All right, our rules. We had two types of special right triangles. We had 45, 45, 90 triangles. In a 45, 45, 90, we have two angles that are the same, which means what about my sides? Two sides are the same. This is also called an isosceles right triangle. Isosceles because two sides are the same. The hypotenuse will never be one of those two sides that's the same. It'll always be the other two. Since I have two sides that are identical, we only have one rule. The hypotenuse is equal to the leg times the square root of 2. And it doesn't matter which leg I choose because those two legs are the same size. Then we had 30, 60, 90 triangles. Because none of the angles are the same, none of the sides are the same. So we have three sides that are all different lengths here. Because of that, we had two rules for this. The hypotenuse is equal to 2 times the short leg, and the long leg is equal to the short leg times the square root of 3. So with my 30, 60, 90s, because they're all different sizes, we have short legs and long legs. With the 45, 45, 90s, I just have leg. No short leg, long leg. There's hypotenuse, and then my two congruent sides. When we look at example A, is that a 45, 45, 90 or a 30, 60, 90? 30, 60, 90. Here's 30, here's 90. Triangle sum theorem tells me this one up here has to be 60 because all the angles of a triangle add up to 180. 30 plus 60 is 90, plus another 90 gives me 180. All right. We need to label our sides because I need to know which one's the hypotenuse, which one's the short leg, which one's the long leg. Which one is the hypotenuse here? X is my hypotenuse. Which one of the remaining two sides is the short leg? Square root of 6. The smallest side will always be opposite the smallest angle. 30 degrees is my smallest angle, and opposite that is radical 6. So that is my short leg, which means y is my long leg. First thing we want to find is x. X is the hypotenuse, so I'm going to use the hypotenuse rule. Hypotenuse equals 2 times the short leg. The hypotenuse is x, so I have x equals 2 times, how big's the short leg? Radical 6. That is as simplified as I can get this. The only thing that I'm going to do to simplify it more is write it down without the multiplication symbol in between. 2 radical 6. That's my answer in radical form. Y is which side? Long leg. So we're going to use our long leg formula. Long leg equals short leg times the square root of 3. So I have y equals radical 6 times radical 3. When we have two different things that are underneath a radical and they're being multiplied together, we multiply them together underneath the radical. So this would be y equals the square root, and then 6 times 3 is underneath the radical. What is 6 times 3? 18. So y equals the square root of 18. And now I have to make sure that that is in fully reduced form. So I'm going to bring that off to the side. Does anything go into 18? 6 and 3, or we could do 9 and 2. Either one, it doesn't matter which one we do. Since the first one I heard was 6 and 3, let's do it with 6 and 3. But the process does not change at all if we were to do this with 9 and 2. We're going to end up in the exact same spot. Looking at this now, can anything go into 6? 2 and 3, right? It's 2 times 3. So 2 times 3, and then I'm going to bring this other times 3 down. 2 times 3 times 3 gives me 18. So far, so good? Do you guys see how I have a pair of 3s under here? Yep, if I have a pair, it comes to the outside. So just the 3, not the 2 3s. Just 1 3 comes out. The 2 doesn't have a match, so it has to stay underneath. So y is equal to 3 radical 2. Beautiful. All right. Part B. What type of triangle is this? 45, 45, 90. Here's 45, here's 90, so this angle down here has to be 45, because 45 plus 45 is 90, plus another 90 gives me 180. 45, 45, 90 has how many sides that are the same? 2. Which 2 sides are the ones that are the same? U and V. Remember, we don't have short legs and long legs on 45, 45, 90s. We just have legs and hypotenuse. If those are my 2 congruent sides, then this side is which one? That's my hypotenuse. All right. We only have one formula. Hypotenuse equals leg times radical 2. So we're going to put in 10 radical 2 here. In the place of the L, I have to put one of my 2 sides. Since they're the same, it doesn't matter which one I pick, but I have to pick one of them. You guys okay if we go with U? I'm just doing alphabetical order. We'd get the same thing if we chose V. U times radical 2. What do I need to do to undo multiplication like this? Divide. What are we going to divide by? By radical 2. If you do it to one side, you have to do it to the other side. Over here on the right, since these 2 are being multiplied, and I have a matching piece on the bottom that's being divided, those 2 matching pieces cancel out. I couldn't do that if it was a plus sign in between them, or a minus sign, but I can do it if it's multiplication. Over here, in between the 10 and the radical 2 up on top, what operation is happening? Multiplication. We just wrote it down without the multiplication, but it's really there. So I have a radical 2 up on top that's being multiplied, and I have a radical 2 on the bottom that's being divided. So my radical 2's will cancel out. 10 equals U. So how big is V? 10. These 2 are the same. All right, one thing quickly before we shut it down for the day. I had a really good question in first period today about what about if it hadn't canceled out over on the left? So here's my example problem to look at that. Let's look at 10 square root of 2 over, and I'm going to make up a new denominator. Let's pretend the denominator was square root of 5. Does anybody remember how we get rid of that radical out of the denominator? No? Okay. Anybody? Yes, we're going to multiply top and bottom by whatever the radical is on the bottom. So we're going to multiply top and bottom by the square root of 5. Up in my numerator, the 10 stays exactly the same because it's not underneath a radical. The 2 and the 5 are both underneath radicals, so those get timesed together. And on the bottom, I have square root of 5 times itself. That's square root of 5 squared, right? Well, what happens when you square and square root? It's going to cancels out. So I just have a 5 in the denominator. So 10 radical 10 over 5. The last thing I have to do is anything that's not under a radical, I have to see if that can reduce. 2 radical 10, yes. So that's how you handle it if it's not the same thing top and bottom, if you can't cancel it out. All right. The remainder of the packet is due for tomorrow. Modules 10 and 11 is due for tomorrow. I'll take questions just like we did today. Monday and Tuesday, you guys will have work days for your cheat sheets. I will also continue to answer questions, but I'm not going to lead anything from up at the front. I'll answer individual questions about anything at all in the packet on Monday and Tuesday. Your final exam in here is on Thursday. It'll be the last final exam of the day on the last day of school. I will not see you at all next Wednesday because you'll have your even finals on Wednesday.